So last section, we looked at hypothesis testing in general, what it means and how to set up and do a hypothesis test, all the way from figuring out what type of test you're doing to making some interpretation of what you've decided based on the information. So here we're going to go and do a little more of the nitty-gritty details that we left out in terms of figuring out how to find that p-value to make your decision and carry out the test. And the particular nature of this section is that we're going to be doing hypothesis testing for the mean, but when sigma is known. So we know the standard deviation of the population. That's the key in this section. All right, so let's just backtrack a little. And we stated this last time, but this is how you're going to use the p-values to make a decision. Then we'll see how we find the p-values, and we'll put it all together in some examples. So the idea is, once you have a p-value, you're comparing it to your alpha, your level of significance. And so if your p is less than or equal to alpha, then you reject H0, the null hypothesis. Remember, the idea here is that that probability, that p-value, is very low. So it doesn't sort of mesh with the assumption about the distribution that H0, your null hypothesis, is saying, so you're going to reject it. If p is greater than alpha, then you fail to reject the null hypothesis. Remember, your decision is only one of two things: reject the null hypothesis or fail to reject the null hypothesis. Then we'll get into interpretations. So let's take a look. So let's imagine we had some p-values, right? And then we'll make our decision. Then we'll backtrack and find the p-values more generally. So let's say you have a p-value of 0.0237, and you've been given that your level of significance is alpha equals 0.05. What would your decision be? Well, in this case, since your p-value, 0.0237, that's your p, is definitely less than 0.05, the alpha that you've been given, then you would reject the null hypothesis. Reject the null hypothesis H0. All right, but now let's redo it. Now imagine your level of significance was 0.01, 1%. So now, since 0.0237, your p is actually greater than 0.01, you fail to reject the null hypothesis H0. Okay, in that case, your p-value was bigger than your significance level, which means that there really isn't something from this sample showing you that there's any reason to reject the null hypothesis. So now let's back up. Now we're going to find the p-value. How do we find the p-value given a certain situation? Well, again, these are probabilities, and it's all about areas under the normal curve. So once we have the standard test statistic, which in this case, we'll be using Z because we know the population standard deviation. So we're going to do this. We're going to find the area that we're going to use. So yes, we're using Z now and then T later in the next section once we do some problems where we don't know sigma. All right, so for a left tail test, P is going to be just corresponding to the area in the left tail. For right tail test, P is going to be the area in the right tail. For a two-tailed test, remember that would come out of an equals, not equals type of hypothesis test. The area is going to be 2 times what we would find in one of these regions. Okay, so it's easy to look up one of these areas, but what we want is we want the entire thing. So we're going to have to take this area and multiply it by 2 in order to get both areas together. So let's look at an example. Find the p-value for the left-tailed hypothesis test with the test statistic of z equals -2.23. Decide whether to reject h0 when the level of significance is alpha equals 0.01. Okay, so we have to go and find this area corresponding to z equals -2.23. So we're going to have to find that area. All right, to do that, let's bring in Excel here. And remember, we're going to give it a z value and then ask for the area, or probability in other words, associated with. Okay, so let's go in here. We're going to use equals norm dot s dot dist, because we're going to be giving it the z value -2.23 true, and that gives us back 0.0129. Okay, so that's 0.0129, and that is the actual area we're looking for because this is a left tail, so that's what the Excel function is giving us. And so that area does then become the p-value. All right, so since we have 0.0129, there's our alpha. All right, this is the p-value. We want to compare it to 0.01, our alpha. All right, 0.0129 is greater than 0.01. P is greater than alpha, so we fail to reject h0. That would be our decision. Let's do another one. Okay, how about a two-tailed? Find the p-value for the two-tailed test when using z equals 2.15 and decide what to do. Make a decision. All right, so if they're telling us z is 2.14, that's what they're telling us, and then we're telling us that the other end of this, so right there is what we're talking about, the other end of this right there is -2.14. So what I have to do is find one of those two areas, one of those two blue areas, and then just double it so that I get both of them together. All right, so this specific area would be what I would get from looking up the area associated with a z of negative 2.14, which would be 0.0162, let's say, 0.0162. But my p has to be twice that because I have both of these areas to account for, giving me 0.0324. All right, so 0.0324 I'm going to compare with, they've told me alpha is 0.05. There's my p, there's my alpha. Compare them. Well, 0.0324 is less than 0.05. This would mean my decision is reject H0 because p was less than alpha.